Assalamualaikum and hello everyone. Today we would like to present about wireless communication system for our video assignment project.
We are the group of 6 boys from the class of F4AS120412, and my name is Muhammad Nazri, and my student ID is 2024X01632. And this slide we will present to Madam Nurul Nazwa and Madam Nur Aimi.
First and foremost, my name is Adif Mustaqim bin Ahmad Nizar. My student ID is 2024679736. Now we move to the first one, which is what is wireless. Wireless is a network between the connection of computers, digital communication devices, network equipment, and various other devices via radio wave. It is applied in places where the wire infrastructure cannot be installed or the price of introducing such a structure is too high. In addition, it has some features that are a great advantage over wired networking, such as customer mobility, easy expandability, and fast and low cost temporarily networking. Now, we move to the what is communication system. A communication system is any complete technology and organizational framework that enables the transfer of information such as data, voice, video, and the other else between two or more terminals. It encompasses both hardware such as transmitters, receivers, antennas, and channels, and software which is protocols, coding, modulation, and the other else, forming the invisible backbone of modern life. You must be wondering why is it so important to have this wireless communication system in our life? Well, it is because wireless communication system is important to provide unmatched mobility, rapid scalability, and seamless global connectivity. By reducing wired cables, it empowers individuals and industries to access information instantly from the legit sources across the internet to explore modern digital economies and advancing the International Telecommunication Union (ITU) standards that connect billions of worldwide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wazif bin Huzalin Deliza and my student ID is 2024679786. So in previous slide I already explained why it's important, and in this slide I'm going to explain to you what is a wireless communication system. So a wireless communication system can be defined as a transmission of voice and data without cable or wires. Next, in place of physical connection, data travels through electromagnetic signals broadcast from sending facilities to intermediate and end user devices. Hi, in this slide I'm going to explain about radio wave. So we all heard about radio wave, right? But do we actually know about it? Let me break it down for you. Radio wave are electromagnetic wave composed of electric and magnetic wave that oscillate. Radio wave travel in space. They can even travel long distance. They travel at the speed of light. They can even travel in empty space as well as in all media. Next one. Radio wave are part of the electromagnetic spectrum together with gamma rays, light rays, and microwave. Radio wave and other wave have characteristic frequencies. A frequency is defined as the number of times it repeats over 1 second. In addition, hertz is the unit in frequency, and 1 hertz is 1 cycle in 1 second. Last but not least, radio wave have a frequency of 3 kHz to GHz. Light wave have frequency ranging from 400,000 to 700,000 GHz. And that's all from me now. Goodbye.
Every wireless communication system operates through a highly coordinated three-stage technical cycle. It begins at the transmitter, where the original source information, such as voice or data, is converted into an electrical signal and encode to protect it from corruption. Next, the signal is pushed into the channel, which is the physical medium. Here, the transmitting antenna converts the electrical current into electromagnetic waves that travel through open air at the speed of light. Finally, the journey concludes at the receiver. The destination device captures these waves, filters out background noise, amplifies the weakened signal, and decodes it back into the original data we can easily understand. But how do these signals travel vast distance without fading away entirely? This relies on a critical engineering process called modulation, because raw baseband signals like human speech have very low frequencies that cannot travel far. We must superimpose them onto a high-frequency carrier wave. Think of this as placing a letter inside a high-speed jet to ensure it reaches its destination. However, these waves are bound by the laws of physics, specifically the inverse square law. In short, signal power degrades drastically in relation to the square of the distance traveled. This physical constraint is exactly why your Wi-Fi or cellular bars drop as you move away from the router or tower. Balancing signal energy against distance is the ultimate key to maintaining a stable wireless system.
Moving on the advantage of wireless communication, there are 4 key pillars that make this technology indispensable today. High mobility and flexibility. First, it enables real-time data transmission while on the move, freeing users from fixed physical terminals. Cost-effective infrastructure. Second, it eliminates expensive trenching and cabling costs, making it the ideal solution for challenging terrains like mountains or densely populated cities. Easy scalability. Third, network can expand and add new users quickly by relying on frequency reuse rather than laying down new physical lines. Rapid disaster recovery. Finally, because it is independent of vulnerable underground cables, emergency cellular or satellite nodes can be deployed instantly during floods or earthquakes. However, we must also consider the limitation and physics constraints inherent to wireless mediums. Wave interference and superposition. Because signals travel through open air, overlapping frequencies can cause disruptive interference, leading to dropped signals. Signal attenuation and path loss. As shown by the inverse square relationship, signal strengths drop rapidly with distance. Furthermore, high-frequency waves, which have shorter wavelength, struggle to penetrate solid obstacles like concrete walls and rain. Inherent security risks. Because signals propagate openly in all directions, they are naturally vulnerable to interception, eavesdropping, and jamming. Finite bandwidth capacity. Lastly, the usable electromagnetic spectrum is strictly regulated, finite resource, resulting in lower total data capacity limits when compared to the near infinite expansion of fiber optics.
Assalamualaikum and hi everyone. My name is Muhammad Nabil Isham bin Muhammad Nasrul. My student ID 2024668396. Today, I will be presenting on the key application of wireless communication. So, there are 4 main application areas. First, mobile communication. This is the most widely used application of wireless communication. Cellular networks such as 4G and 5G enable voice call, text messaging, and high-speed internet access, allowing people to stay connected anytime and anywhere. Second, wireless networking. Wi-Fi technology provides flexible and high-speed internet connectivity in home, office, school, and public areas. It allows multiple devices to access the internet without the need of the physical cable. Third, satellite communication. Satellite systems play a crucial role in long-distance communication, especially in areas where terrestrial communication infrastructure is unavailable. Common applications include GPS navigation, satellite television, weather forecasting, and internet service in the remote regions. And finally, medical and healthcare applications. Wireless communication supports patient monitoring, remote healthcare service, and wireless medical devices. It enables real-time transmission of patient data, improving healthcare efficiency and allowing doctors to monitor patients more efficiently.
Let me talk about differences between wireless and wired communication system. For the wireless communication is a method of transmitting data without using physical cables. It uses electromagnetic waves such as radio waves, microwaves, and infrared signals. As we can see, there are many types of wireless communication such as satellite, radio, Wi-Fi, Bluetooth, and mobile. The first characteristic is cable-free connection, where data is transmitted through the air instead of wires. Second, greater mobility allows users to move freely while staying connected to the network. Third, flexible deployment. Flexible deployment means wireless networks can be installed and expanded easily without extensive cabling. Lastly, convenient access enables users to connect to the network from different locations within the coverage area. For the wired communication system, wired communication is a method of transmitting data through physical cables, such as copper wires or fiber optic cables. The first characteristic is physical cable connection, where devices are connected using cables to transfer data. Second, limited mobility means devices must remain physically connected to the network. Third, fixed infrastructures requires additional cabling when expanding or modifying the network. Lastly, reliable access provides a stable and consistent connection with minimal interference, making it suitable for applications that require high reliability.
So, the conclusion is wireless communication systems serve as a cornerstone of a modern digital economies, offering unparalleled mobility, rapid scalability, and robust disaster recovery by eliminating wired dependencies. However, its reliance on open-air electromagnetic propagation means it is inherently bound by physical constraints such as signal attenuation. With interference and infinite bandwidth capacity, ultimately the future of global connectivity relies on engineered solutions that maximize the structural advantage while mitigating the natural limitation of the physics behind radio wave. So that's all from me. Goodbye.